All right, so we've gone over sine, cosine, and tangent trig functions, right? Now we're going to talk about sine and cosine of complementary angles. Who remembers what complementary angles are? What do they add to? Complementary, that's supplementary. 90, right? So let me ask you a question. In a right triangle, you have a right angle, yes, and the two acute angles, right? What do those two acute angles have to add to? 90. So they are what? What are they? Complementary, right? Okay. And you remember when we were doing the sine of one and the cosine of the other, what changed? Just the opposite adjacent changed, right? So wasn't the sine of one the same as the cosine of the other one? Wasn't it? Because you changed the opposite and adjacent sides when you went to the other reference angle? Well, let's just do this. Note number one, actually. Whoop, right there. So, note number one, complementary angles. We already established, we know they add to 90 degrees, right? Okay? So let me draw a right triangle. And I'll call it A here, B, C. C is the 90, okay? A and B are the two, you know what acute angles are, right? They're less than 90. They have to be. If this one's 90, they have to be less, because otherwise it all add up to more than 180, right? Okay. So what is the measure of angle A plus the measure of angle B? 90 degrees, okay? That means maybe if we were to solve for, say, angle A, what would we do to solve this for angle A? How do you get angle A by itself?
By 90 by 2.
You're assuming they're equal. Subtract angle B. So measure of angle A would be what? 90 minus measure of angle B, right? If I subtract it from both sides? Well, what would, oh, that's an A. Sorry. It's kind of important to have in there. Measure of angle A. Okay. Okay, so then what about the measure of angle B? What would we get for that? Starting with this. What is it? What? Well, come on now. You're stuck on the measure of angle B? What do you do? What? Subtract angle A from both sides. So what is measure of angle B? Equals, yeah. 90. 90 angle A? Okay, minus measure of angle A. Right? So let's say that you get the two acute angles, and let's say angle A is 40 degrees. What's the measure of angle B? 90 minus 40, which is what?
50.
Okay. You get that, that's all it is, right? You find one by subtracting the other from 90, because they add to 90. That's all it is. Okay? So let's keep that in our hat for now. Let's go back here. All right. So what's our trig table? We kind of touched on yesterday, but if we take the sine of one acute angle, use that as our reference angle, and then we switch over to the other angle, will the sines be the same? Will the opposite over hypotenuse be the same for both angles? They will. So if I go from one acute angle and say this is opposite and this hypotenuse, and then I go to the other angle, is it the same opposite and hypotenuse? Huh? What?
No.
No. Well, what is the same always, though? What part? Hypotenuse. When you go from one angle to the other, go to the opposite and adjacent change for each angle, right? Okay. So that means like the sine of one of the angles is opposite over hypotenuse. What would that mean? What would be the equivalent for the other angle? Not sine, but what? cosine, right? Because now the one we were looking at, the sine, had an adjacent, right? But now when you go to the other angle, that's now its opposite. We'll look at it, right? So let's take the sine of angle 5 degrees. They say it's equal to cosine of 85. Right? Why is that? What about 5 and 85? They add to 90. So they could be the acute angles of a right triangle, couldn't they? Let me make a sketch of just this one here. Right? So let me sketch just rough. So this would be, it's not the scale by any means, all right? So I'm drawing this here. So if this angle is 5 degrees, right? This angle is 85 degrees, okay? They add to 90. Okay? So, I don't know, let's take, let's say that this side length here, let's call this A, and we'll call that B, and we'll call that C, right? What is the sine of angle 5, the way I've drawn it? Or sine of 5 degrees? What over what? Huh? No way to know that? Sine of angle 5 degrees here in this. What over what? Everybody put stuff there though. A over C, right? Now let me go to 85. Will 85 here have the same sign? Will it still be A over C for the sine of 85? What will the sine of 85 be? B over C, all right? But what function on 85 would be the same as A over C? Here's 85. What is A to it? And hypotenuse. So what function of 85 would be the same as A over C? So the cosine of 85 also equals A over C. See what I mean? That's C. Why did they switch like that? Because it went to the 85 angle. What changed? What changes when we switch to different angles in the triangle? The opposite and adjacent, right? When we switch to the other angle, one becomes the other now, doesn't it? Right? So the sine of one angle equals the cosine of its complement. Isn't 85 the complement of 5? Because it makes it add to what? 90, right? So in any right triangle, anytime you have two angles that add to 90, okay, here's what we're getting at. The sine of one of these angles is equal to the sine or the cosine of the other, right? Take a look up here. You see the sine of angle 5? What's its value? Okay. Now go to the cosine of 85. Cosine of 85. What is it?
0.0.
Okay. So the sine of one angle equals the cosine of the other. If the two angles add to what? 90. You get that? Okay. Well, how did we find, let's see if we know that one's 85, how do we find the other one? 90 minus 85 gives us the 5, right? So wouldn't that mean the sine of one equals the cosine of 90 minus the other? Or 90 minus itself, right? Something like that. So here, sine of one angle, if they add to 90, equals the cosine of 90 minus this angle. Why is it 90 minus? Because the other angle is complementary to it, right? Does that make sense? And right. Let's look at some of these examples here. For this illustration. Oh, let me do this first. Before I get to, maybe we'll clear it up here. So let's see. Let me just draw a picture that might clear things up. Yeah. Okay, so note number 2. I'm going to draw a triangle. We'll keep it a simple. Let's make it like a 3, 4, 5. All right, so we'll call that 3, 4, and 5. And this will be A, B, C. Okay? What is the sine of A in this case? 4 over what?
4 over 5.
Okay, 4 over 5. All right. What is the sine of B?
3 over 5.
Because we switched the opposite and adjacent, didn't we? 3 over 5. Okay. But now, we know the sine of A is 4 over 5. What's the cosine of B? Cosine of B.
3 over 5.
Cosine of B. Oh, it's this. So doesn't this also equal cosine of B, which is also 4 over 5? Right? What does the sine of B equal in terms of A? Cosine of A, which is also 3 over 5. You getting that now? So when you switch from one angle to the other, they add to 90, right? The sine of one equals the cosine of the other. All right, you feeling that a little bit? Okay, because you just switch an opposite and adjacent, right? So sine of one is always going to equal the cosine of the other if they add to what? Because the two acute angles in a right triangle always add to 90. Okay, let's go back here. All right, so down here we have this triangle with a 67-degree angle, right? What's the measure of this angle here? 23 degrees. Okay? So the sine of this one is opposite over hypotenuse. Well, the sine at 67 in this case is opposite x over hypotenuse z, right? What is the cosine of the other angle? 23. And this is 67, whatever. I don't know why they did 2. So the sine of that angle 67 is x over z. What's the cosine of 23? Now it's adjacent, right? So that is equal to that one's cosine. And what do you know about the two angles, 67 and 23? They add to 90. What do you know about the acute angles in all right triangles? They add to 90. So when they add to 90, you can always assume they come from a right triangle, and you're just going to switch opposite and adjacent, okay? Let's look at the cosine of 67. Is what over what? Y over z. What's the sine of the other angle? Opposite y over z. So the sine of one equals the cosine of the other one. Okay? But let's think of it the other way. If you have two angles and someone tells you the sine of one equals the cosine of the other, what do you know about the two angles? They add to 90. Right. Right? So if you're told if sine A, if the sine of some angle A equals the cosine of some other angle B, what can you again tell me about angles A and B? You just did it. You just said it. If the sine of angle A equals the cosine of angle B, what can you tell me about the two angles? Yeah, they add to 90. So then the measure of angle A plus the measure of angle B equals 90 degrees. Right? So if you're told the sine of one angle equals the cosine of the other, you know the angles add to 90. Because if the sine of one equals cosine of the other, they must have come from the same right triangle, right? And when you go from one to the other, you just switched opposite and adjacent. And so they have to add to 90. Perhaps some examples to illustrate. Let's go to the next page. So here's how you set this up. This first problem, I'll walk you through it. So you know that the sine of angle x equals the cosine of angle 63. Well, that means if sine and cosine equal each other, they must have come from the same right triangle, which means that this angle and this angle add to what? So here's the equation to figure out what x is. X plus 63 equals 90. You got that? If you're told the sine equals the cosine of the other, they add to 90. So what does x equal here? 27 degrees. That's not so hard, right? If you ever see the sine equaling the cosine, the two angles add to 90, right?
What about the next one?
Does the sine of one equal the cosine of the other? What's your equation then to solve that for x? What was it here?
34 plus x.
Or x plus 34 equals 90. Now, I know a lot of kids, like on a test, you'll tell me that, x equals 34. No. They don't equal each other necessarily. What do? They add to 90, okay? So I want you guys to take a minute. This is your setup. If the sine of one equals the cosine of the other, they add to 90. And that's how you solve for the missing angle, okay? Or whatever part of it is. They'll get a bit more complex down here, but it works the same. So I'll give you a minute to work through that. All right, what was your equation?
I chose 34 plus x equals 90.
Subtract 34 from both sides. Simple enough. We good with that? Okay. Anybody get number 3 yet? You're 45? Or do you have a question? Yeah. So your equation was what?
45 plus x or x plus
Or x plus 45 equals 90.
x equals.
Well, this is the only time they'd equal each other, right? If one of them was 45. Right? Otherwise, they're not going to equal each other. They just add to 90. Okay. What number 4? Somebody have an equation for number 4?
So x minus 1 equals 11.
Oh, when you saying that angle equals that angle if the sine of one equals the cosine of the other? They add to 90. So this angle, 2x minus 1, plus this angle, 11, equals 90. Right? If the sine and cosine are equal, don't tell me the angles are equal. Tell me that they what? Everybody. Add to 90. There we go. Solve that, right? So that's what? 2x plus 10 equals 90. 2x equals 80.
X equals 40.
40. Oops. Done? Getting the handle of this now? If the sine equals the cosine, the angles what? Add to 90. Does everyone know that? Okay, don't answer me that. That way I know you know.
40 and 11.
Keep repeating myself. Well, what's your equation for 6? That's not an equation. Equals 90, yeah. That's algebra, right? Everybody got number 5 yet? How many got 15? Because your equation is this angle, x plus 5, plus this angle, 4x plus 10, equals 90. Combine like terms. 5x plus 15 equals 90, right? Subtract 15. So 75. 15. What's the equation in number 6?
1 half
So you having trouble solving that?
x. I got
What'd you get?
x equals 44.
How many got x equals 44? So what did you do? You combine like terms. What did you get?
I got 1 half x equals 66.
What did your x? What's 1 half x plus x?
I said 1.
Oh, 1.5. Oh, so we did like 1.5x for the handle that fraction. That's fine. Can I show you guys another trick? Because I know you hate fractions. I bet you'd like that not to be a fraction, right? And that way you could just work just like these, wouldn't it? Right? You can use this trick. I don't think so. Whatever. Does anybody know a way I could make that fraction go away? Like, what could I do to 1/2 to make it a whole number? Make it a whole number. If I have half of something, how do I make it whole? Double it, right? In other words, multiply by what? 2. But if I multiply any term in here by 2, what do I have to do? We'll put everything by 2. Just watch this. Everything times 2. What's 2 times 1/2 x? X plus, what's 2 times x? 2x. What's 2 times 24? 48 equals, what's 2 times 90? See, no more fractions, right? Feel free to use that trick. It can come in handy if you have more messy fractions, right? So let's see, that's 3x plus 48 equals 180, right? So that's 3x equals 32, right? What's 132 divided by 3? 4, 12, 44, yes. So that works. Some of you could do it like he did, make it 1.5. Okay? So we get the idea there a little bit? So, if 2 angles add to 90, what can you tell me about their trick? What equals what? The sine of one equals what? Cosine of the other. Let's do the converse. All right, ready? If you're told that the sine of one angle equals the cosine of another angle, what can you tell me about those 2 angles? They add to, they're not equal. They add to 90. Now, they could be equal if one's 45, right? But that's just a coinky dink, okay? They add to 90. So let's go take a look at some Regents questions here. Well, you know what? Why don't we take a quick 5-minute break and then we'll look at these Regents. So this first one's just like straight out of the complementary handbook. Cosine of b is 5 over 13. What else equals 5 over 13? Sine of it, right? So if they come from the same right triangle, they're acute angles, the sine of one equals the cosine of the other, right? So, everybody get that?
You got it right. Oh my God, I am so hard.
They came out of the same right triangle, so the sine of one has to equal the cosine of the other. Because angle A and B add to what? 90, they're complementary. Okay, do number 2. That came out wrong.
Do number 2.
So it says the sine of one equals the cosine of the other. So we know that they add to 90. Right? So 2x plus 50 equals 90. 2x equals 40 equals 20. Are we good with that? So choice 1. On to number 3. Actually, this is right out of the handbook as well, isn't it?
It's got to be number 2.
Sine of 57 is equal to what?
Cos 33.
Why is it the cosine of 33?
You add them both together, it's got to get 90.
Measure of angle A plus measure of angle B.
See, that now makes 57 and 33 the 2 acute angles of a right triangle. And we know that the sine of one equals the cosine of its complement. 33 is called the complement of 57. These aren't too bad, right? There's another one like we just did. Pauses. I think you guys are getting this now. That's our equation, right? They add to 90 because the sine of one equals cosine of the other. Everybody get this?
Yes.
How many got 25?
Wait.
Okay.
I didn't.
So we get, let's see, 3x, that's 2x plus 40 equals 90. 2x equals 50. X equals 25. Any questions on that one? All right. On to number 5.
AC.
You know why they said that? They're eliminating the one time that the angles could be equal. See what I mean? Like if one of them was 45, it'd be isosceles, so they're saying it's not isosceles, right?
Number 1.
says number 1. What do you guys think?
Yeah.
Yeah, that's right. So sine of B in that triangle's got to be equal to cosine of the other complementary one, cosine of A. You get number 6. I think you got it now, right?
Yeah.
Your equation's going to be 2x plus 7 equals 4x minus 7, right? No. I don't know. You'll do it that way in the test, but I'm glad you said no, at least for now.
Really not.
What? You didn't? You don't get it?
I didn't understand.
Oh. What'd you get? How many got 15? Well, this kid over here, he's on fire today, man.
Yeah.
We better call the Schmung Fire Department and have him put out.
Right away.
So the equation was 2x plus 7 plus 4x minus 7 equals 90. So that's 6x, oh, 7's go away, 90, x equals 15. Everybody agree? Okay, we're almost through here. More here. Next page. We have to do a little explaining here, so I'll let you read it. What do we think? Are they both correct?
Yes.
Okay. Everybody agree that they're both right? So now we just have to explain why. We've got to find some words here, right? So let's start out with in our explanation with yes, right? You got to have that, and then you got to have an explanation.
If you add 28 plus 16, you won't get 90.
So the measure of angle H, you're saying, is what minus what?
8. What?
Measure of angle H equals what? Minus what?
J minus C.
In other words, 90 minus 28, which is what? 62 degrees, right? So that makes those two angles what? Complementary. And since they're complementary, what do you know?
Add 90.
Well, about their sine and cosine.
Um,
So since really angle G and angle H are complementary, going to the picture there. What can you tell me about their sine and cosine? What? What?
Add to 90.
Sine and cosine don't add to 90. They're not even degrees. We just are with the two angles add to 90. What do you know about their sine and cosine? What? They're equal. Sine of 1 equals a cosine of it. So we can say the sine of G equals a cosine of H. And that's what they have up there. Right? Okay. On to number 8. And the wording, obviously, right? You might have different wordings when you sit down and do it yourself, as long as it contains the essential stuff, right? Okay. On to number 8. This one you need to think about. They're not asking what the measure of the angle increases. What are they asking? Oh, if the cosine of the angle increases or decreases.
Yeah.
If the sine of the other one increases.
Yeah,
It decreases.
Well, hey, what, don't A and B add to 90? So what do you know about their sine and cosine? They're always what? Oh. So if one increases,
Does it decreases?
to stay equal, it has to also increase, doesn't it?
Makes sense.
If sine equals cosine and sine increases, then the cosine has to increase if they are equal. You're thinking about the angles. We're not talking about the angle measured in degrees. We're talking about their sine and cosine. If the sine of one increases, right? So what's our answer? Cosine B does what? Well, why do they have to stay the same? Because what do you know about the two angles? Yeah, they had tonight. Since the measure of angle A plus the measure of angle B equals 90, right? They're complementary, something like that. Okay? And what does that mean if they're complementary? About their sine and cosine, not their degree measure. I guess we didn't cover that. If they're complementary, what does that mean about their sine and cosine?
Dirty.
Yeah. And the sine of A equals the cosine of B. So the sine and cosine go up and down together because the sine and cosine of them are equal. Please don't confuse that with the one angle gets bigger. Yeah, the other one's got to get smaller to keep it at 90, right? That's not what they asked. They asked what the sine and cosine. And you know if they add to 90, sine and cosine are always what? Equal. You're funny guys sometimes. Let's go to number 9. You should be reading number 9. To solve it, right? But what? You gotta explain it. Sine of 73 equals a cosine of R. If sine of 73 equals a cosine of R, what can you tell me about angles 73 and R? Right, sine equals cosine, they have to add 90, they're complementary, right? So that would be our explanation, right? Because it did say explain, so we need some words here, right? So since they told us the sine of 73 degrees equals a cosine of R, they are what? Say it again?
Equal.
No. They're complementary. So now that explains what we're about to do, which is solve for 1, right? How are we going to do that?
Still right. We're still right.
No.
Yeah, because it says they are equal.
The sine and cosine, not the angles. You're conflating the two. The sine of an angle is not the angle. The sine is opposite over hypotenuse.
Exactly.
All right. So what is it? How'd you get that? Measure of angle R plus 73 equals 90, right? Because they're complementary. Subtract 73, measure of angle R equals, what'd you say? 17 degrees. Simple as that. Okay, any questions on that?